Okay, here's the second part of the video. We're gonna do 2 more problems. They're gonna look like they're just as easy. They are, but this is what's gonna be different here. Again, here's our tangent line to the circle, so that makes this one the right angle. Okay, and it looks like we have 2 sides, right? It looks like we have 2 sides. And the problem with this one is it's not asking you for the whole side. It's asking you just for this little piece right here. And we'll get to that at the last. It's not asking you for the whole thing. It's just asking you for this little segment here. So we're gonna worry about that last, right? There's a question mark right there. Just how much is that little piece? But right now we're not gonna worry about that. We're gonna be happy. We know 2 sides. I'm going to know that this is let me draw a little bigger here like this. And what are the 2 sides that I know? 11.4 and 15.2. And I'm gonna not worry about that. I'm gonna just find the whole side, right? I'm gonna find the whole side and I'm gonna call that x. So good, we can obviously use Pythagorean theorem. So that'll be a squared plus b squared equals c squared. And remember, c is your hypotenuse, so that's the one that I don't know. That's going to be x squared equals, and then it doesn't matter which one's a or b, so 11.4 squared plus 15.2 squared equals x squared. Okay. So that'll be 11.4 squared is 129.96 plus 15.2 squared. Yeah, 15.2 squared equals 231.04. Okay, and then I'm going to add these two, so 231.04 plus 231.04 plus what? 129.96. Oh, it's exactly 361. Look at that again. It's exactly 361, and I think 361 is another perfect square number. That's going to be pretty rare sometimes, but maybe it is, maybe it isn't. I don't want x squared. I want x. So remember, you took the square root of both sides. So whatever the square root of 361 is, and I think it's a perfect square number. I could be wrong. Let's see, the square root. No, I think I'm wrong. Let's see. 361 is? Oh, it is. It's 19. Okay, I thought I'd seen that before. 19 is the answer. Oh, actually, no, I take that back. 19 is not the answer. 19 is the whole length. You see, but that's not the question. See, now that's when you got to take this value, I don't want to say answer, and bring it back here, because they're not asking you for the whole thing. The whole thing is 19. That whole hypotenuse side is 19. I don't want that. I don't want that. I just want this little piece. Anybody have a clue how you're going to do it? Well, let me zoom in. Very easy, guys. So all you have to do is this. Remember what you know about circles. Remember that you know that if this is a radius, which is 11.4 from the center to that edge of the circle, that means that any line from the center out to the edge of any straight line, right, to the edge of the circle is also going to be what? 11.4. So if this is 11.4, guess how much is it from there to there? It's also what? 11.4. So if the whole thing is 19, and from here to here is 11.4, how do you do this? How do you find this one? Well, you can do the segment addition postulate, right? This plus what equals this? Or you already know that 19, and if I subtract 11.4, will tell me the rest, this little piece that's left over. So that's how you find that leftover piece. That would be 19 minus 11.4 is going to give you 7.6. That's how much this little piece is. 7.6. That is the answer for this problem, okay? That is the answer for this problem. So the answer for this problem for this little piece is 7.6. Okay? So remember, they were not asking you for the whole length, but you needed to still find that whole length. And then if this is a radius and it's 11.4, that's 11.4. So 19 minus 11.4 tells me this leftover little piece. 7.6 is the answer for number 3. All right, let's do another one. Kind of similar. All right, number 4, last one. Which one is your 90-degree angle? Right here, the tangent to the radius. Right here is 90 degrees, right? That's my 90 degrees. And do I have 2 known side lengths? Yes, I know this is 9, this whole side is 9, and they're telling me that this whole thing is what? 15. Okay, so notice that again, they're not asking you for this whole side, they're just asking you for a section of it, a segment of it. Okay, we'll get back to that. Right now, you're not worrying about that. Right now, you're just going to worry about getting that whole side length. So if I look at this right triangle here like this, I know that's 9, I know that's 15, and I'm trying to find the whole side right now. I'll just call it X, right? Oops, sorry. I'm just going to draw it again. I know 9, I know 15. And let me zoom out a little bit here. And then I know I'll be able to use Pythagorean theorem, right, to find this side. A squared plus B squared equals C squared. And which one's C? Always look for that one first. That one always put for this one. The hypotenuse is your C. That's your C right there. So that goes there. Put that one first all the time. And then this is the A and B. It doesn't matter which one. So I'm going to put x squared plus 9 squared equals 15 squared. So now I'm going to continue and say x squared plus, what's this? 9 times 9, 81 is equal to 15 times 15. I believe it's 225, but let me check. What is it? 15 times 15? 15 squared. Oh yeah, I'm right, 225. Okay. And then I'm going to do what? Try to get x squared by itself. So that's x squared plus 81 equals 225. So I got to do minus 81, right? That's going to leave you with x squared is equal to 225 minus 81. I don't know what that is. 225 minus 81. 144. Oh, I like 144. You know why? Because I know that's a perfect square number. When I take the square root of both sides, you guys probably know what it is, right? I don't need a calculator, but I'm going to do it anyway. The square root of 144, I know is 12. 12 times 12 is 144. I got my answer for x, 12. But that's not the answer for this problem, okay? So watch here. Why not? Because now when I get this information, right, remember what happened in the previous problem, they're not asking me for the whole side. They're telling me that from here to here, right, this whole side is 12. This whole side is 12. But they're not asking me for the whole side. They're just asking me, see how the question mark is only on this one right here? If they were to want you to know the whole side, they'll show the whole arrows like this. They'll put some arrows like this, and they'll make it obviously. See this arrow right here where it says 15. That's how you know it's the whole thing. But if they just have a little question mark here, they just want that. Well, if that's 12, isn't that a diameter? Isn't that a diameter, right? Going back to what you know about circles, right? Isn't that a diameter? I got a circle like this. Oh, let me draw a nice circle. If you got any line that goes through the diameter, oh, I don't have a straight edge. Let's see, I'll use this one. Oh, I'm trying to look like this. If you got any line that goes right through the center, like that, that's a diameter, right? That's what I'm looking at here. And if you know that the whole thing is 12, if the whole thing is 12, doesn't that make this 6 and 6, right? Because it's a radius, and the radius has to be the same. It has to be 6 and 6. If the whole thing is 12, the diameter is 12, then if this is a radius, well, you just divide it by 2, right? So they just want to know what this radius is. Well, guess what? We already said the answer. The answer is what? Not 12. The answer for this little radius part is what? 6. 6 is the answer. Okay, there you go. Good luck. It's an easy assignment. All right. That's it.